Now we're going to move from measures of central tendency to variability among the scores. Now, remember we went over already the measures of median, mean, and mode. Your mean is your average. You add up all of your scores, divide by the number of scores to get your mean. The median is the number of scores plus 1 divided by 2, and then you count over as many to find your median. And remember, they have to be in numerical order. And the same thing with your mode. They have to be in numerical order, and basically you're looking for the score that is seen most frequently. So now what we want to look at is the variability within data. When we are talking about measuring variability, it's a measure for the dispersion or spread of data in a distribution. Remember when we looked at the bell curve and we had the distribution of scores? That's considered a dispersion. Dispersion is how are the scores dispersed out among all of them. So what's important when we look at this is the variability, how the spread of data is dispersed in a distribution. First, I want to go over the range of scores and the mid-range of scores. We're talking about in a group of scores, what's the range from the smallest value to the largest value. So the way to find that out, and this is called the dispersion of scores. We're going to see what's the range from highest to lowest. So in this range of scores right here, you would subtract the largest, the smallest from the largest. So you get 4. So this means that the scores ranged among 4 scores. Here you have a lot different, but the range here is 98. That's your level of variability, because it's the highest, subtract the lowest, you get 98. So it's basically 98 places between the first one and the last one. Now in the last video I talked a little bit about quartiles and interquartiles when we talked about the median. This splits your data in half. So you might be looking at your data just in the median and looking at it from 50%. You might want to look at quartiles. This splits the data into 4 parts. This is very familiar. This is very common, where the first quartile would be the first 25%, in the 50% quartile, 75%, and 100, and so forth. But percentiles splits the data into 100 parts. But as again, the quartiles are the most common in the median. Here's an example of the quartiles. As I said, it's a distribution on the range of scores that are split into 4 equal parts. So you have you have 4, but we really only refer to 3. We have the 25th percentile would be up from 1 to 25, and the 50th percentile, which is our median quartile, and our 75th percentile, which is in our upper quartile. These are just ways that we describe our data. It's not anything that you have to calculate, but these are ways that you might be reading an article and they might say the majority of the results were in the upper quartile. So we know then it's skewed and it's in that upper 75% quartile. Now we're going to get into variance. This is fun. This is the measure of variability for the average square distance that scores deviate from the mean. Oh my gosh. What the heck does that mean? Does that scare you? Our variance will always be positive. A negative variance is meaningless, doesn't show us anything. So the value is going to be, if you have a 0 value of variance, that means there's no variability among the scores. They're all predominantly the same. Or if it's greater than 0, it means there is a variability. Variance is measured, and this is the preferred measure of variability because, again, all the scores are included in the calculation. Now, again, remember, these formulas are really for information only. If you can, if your mind works that way, that you want to see the formula for how you're finding a population of scores and the sample of scores, this is what you would use. But the variance measures the dispersion of scores from their mean. So we have to have the mean in order to find the variance. And what this is telling us is how far are the scores from the mean. That's what you're going to see and you're going to read in your articles. Now, most commonly, you're going to see standard deviation. Standard deviation is if you look at what it means, it's deviating from the norm. I'm sorry, from the median. Well, am I going to get this right? It's deviating from the mean. It's telling us how far, what's the standard measure from the mean of our scores. So it's called the standard deviation. This is what is used to measure variability for the average distance that scores deviate from the mean. So in other words, okay, what I've done here is I have written it out in a Word document. So I can go over it and show you a good example of what standard deviation is. The standard deviation is an important value because it's used most commonly to determine the variability in a set of scores. So we want to know, how do they vary? How are they different? And of course, what we're looking at centrally is what? Guess, come on, the mean. So we want to see how far every score is from the mean. Now, I'm going through this so you can see the calculation, but I want you to know you're not responsible for it. And if it doesn't make any sense, don't worry about it, because I want you to understand just what a standard deviation is. So the first thing we do is here are our scores right here. We have written them out. They're in no particular order. The way we find the mean is we add them all up and divide by the number of scores. And it turns out that the mean is 6. We then subtract the mean from each score. Now, this is usually done in a table, but remember, this is done automatically in a software program. So we don't have to do this computation. But we subtract the mean from each score, then we square that result, which is the difference for each score. We square that score, and then we add up all of those squared numbers. And when we do that for this, the total is 68. Now, the next step is we look at, we need to know the number in our sample. And in this case, the number of scores up here is 10. So the next computation is to subtract 1 from our sample, which we have 10 minus 1 equals 9. Yes, we're in first grade. The next thing we do is we divide. We divide this number. So we're going to divide 28 divided by 9, and what we come up with is 3.11. As I said, again, the calculation is not important, but I want you to see where it's coming from. Then what we do is we find the square root of 3.11. The 3.11 is actually the total variance among these, among these scores up here. But when we square root that variance, we come up with 1.76. Ta-da! That is our standard deviation. Now, the next thing we want to do, I want to show you what this means. Why is this even important? So the next thing we do is we have our scores listed in numerical order. And this way, not only can we see the range, and what's the range is 8 minus 3 equals 5. So that's our range of numbers. They range over a scale of 5. The next thing we want to do, we already know the mean, which is 6. Now, if we want to look at the median, remember how we do that? The total number, which is 10 minus, I'm sorry, the mean, which is 6 plus 1, and then we add through. I'm sorry, it's 6 minus 1 is our median. Remember, now this is not the median, but this is where, how far we're going to count in to find the median number. So we're going to go 1, 2, 3, 4, 5. So 6, 1, 2, 3, 4, 5. So 6 is our median, the number 6. 6 is the median number among all these scores. Now, and the next thing you want to look at, we're just doing this, is the mode. What is the mode when you look at that? It's 8, right? It's the most frequent score you see in a set of scores. I'm going to find that. I'm having a few technical difficulties. I seem to be hitting the wrong button. So if I'm repeating or I over recorded on some of this, I'm gonna repeat myself again. I'm not sure how much went, but as we found out, the mean is 6, and that's by adding them all up and dividing by the number, which was 10. So our mean is 6. The median was found by subtracting 1 from the mean, which is 5. So we count in 5 places and we get 6, the number 6. So 6 is our median number, and our mode is 8 because 8 is the value that is seen more frequently. So what this tells us, I know, absolutely nothing. Why are we doing this? This tells us, after looking at all of the variants and how far apart from each other they are, and how far apart they are from the mean of 6, the standard deviation of 1.76 is the average distance that the scores are from the mean. So now, when you read in an article, if you were looking at here are your scores, and you were told the standard deviation is 1.76 from 6, so we know that averaging, because that means that most of them are within two scores, and this is pretty good. That means they're all pretty close to the mean. Now, I'm going to throw another wrench in this. What we look at sometimes is we want to know how many standard deviations that number or a score is from the mean. So if we go 1.76 from our mean of 6 is 7.76, right? So one deviation from the mean is going to be 7.76. 2 standard deviations from that would be doubling 1.7. So 1 standard deviation is going to be equal to 1.76. 2 standard deviations is going to be equal to, so let's say I'm doing this in my head, so I'm just going to kind of average it. It's going to be an average of 3.5, 1.7, 3.4. So, okay, so our 2 standard deviations would be 3.5. 3 standard deviations would be 3 times 1.76. So for a range of scores, and all I wanted to tell you was, well, the score is that we looked at, most of them, the standard deviation is 1.76. So we know it's within that range, and that's the variability. That's what it's telling you. That's what you just need to be aware of more than anything is the standard deviation. When you read that in an article that the standard deviation is 0.5, well, that means that they're all clustered around that mean. So you're going to have really close to a normal distribution at that point. But And the larger the standard deviation, the farther the scores are from the mean. So within this, we know it's only 1.76 average from the mean, which keeps them pretty close. They range from 3 to 8. It's a 5-point range. Does this make sense? We will go over this again on Monday, but I want you to have had some basics before we talk about it on Monday. I want to give you another example of the standard deviations around a normal distribution. Here, let's look. We're looking at a very high number in our sample. We have 5,000 employees. And so what we're looking at in this example is the time that those employees think about work in hours. So under a normal distribution, we see that the mean is 12. So we're saying that on average, these 5,000 employees think about work for 12 hours per day. Ooh, that'd be good, wouldn't it? So on an average, these employees think about work on 12 hours. The standard deviation, after being computed through the computation I just showed you, or by putting it in to your software program that computes and spits out and tells you the standard deviation is 4, we know that on average, all of the scores are 4 points from our mean of 12. And what we'll see here is this is just rule of thumb. This is just rule of thumb to know this, that in a normal distribution, one standard deviation, which is 4 points from 12, would be 8 to the left, 16 to the right. 68% of all the scores fall within one standard deviation from the mean in a normal distribution. Now, let me say that again. In a normal distribution, the numbers, 68% of the numbers fall within one standard deviation. You see what I'm saying? Right here, one deviation. In a normal distribution, 95% fall within 2 standard deviations. See, and you can see this by 12 minus 2 standard deviations of 8 is 4. So 95%. This is on a normal distribution. This is just FYI information to try to help you understand what we're talking about with a standard deviation. Now, as I said, I already showed you this, that scores can either vary, they're greater than 0 or not vary at all, which would be equal to 0, which would mean what? That they're all on the mean, right? And a negative variability doesn't tell us anything. The standard deviation is used to describe quantitative variables. Remember what we talked about? Quantitative variables, those that are ratio or interval. They can't be used on categorical or qualitative. Some more information. When you're looking at articles, and it's interesting when you analyze them, because when you look at them, some studies don't report the standard deviation and the mean together. Well, we need both of those. Those are very important. So reporting them can inform us of a distribution for close to all recorded data. And so whenever we have the standard deviation and the mean, that tells us a lot about our data. Don't be scared about this. We are going to go over this in an article on Monday. We'll pull out those articles that I put on Blackboard, and we'll look at the standard deviation and the means as they're reported within those. Let's see if there's anything else we look at. Nope. Okay, that concludes our information for class on Monday in our talks on descriptive statistics. Again, I wanted to go over this ahead of time so that you could have the time to listen to it and try to get it in your head a little bit, and we will talk about this on Monday when we go through those articles. But also, too, I'm going to do the voiceover. Yes, Chris. I'm going to do it over for the quasi-experimental and the experimental uh, PowerPoint. That'll be up next.